Okay, the fifth problem is a problem similar to your quiz on this, where you are doing a titration, calculating the pH of the final titrated solution. And so the first thing, or one of the problems that you can be given is either going to be, you have to decide where you're going to be. It's before the equivalence point, at the equivalence point, or after the equivalence point. So on this problem that I've done several times, at least, well, not several, 2 times in class, you're supposed to calculate the pH, 25 mils of 0.1 molar acetic acid titrated with the strong base, 10 mils of 0.1, and I give you the Ka. So calculate before equivalence, where are you as far as moles? You've got 0.025 times 0.1 will give you the moles of acetic acid, and 0.010 times 0.1 will give you the moles of the base, and you know there's a reaction between it, and so you have leftover acetic acid. So I had the acetic acid, I'm titrating it, and so I have not added enough base to neutralize all that acid, so I am before the equivalence point. Okay, so if I'm before the equivalence point, here is I'm looking at my equilibrium for my acid, my acetic acid. Okay, I have left over 0.0015 in a total of 35 milliliters. And what I formed with that reaction was my acetate. I only have 0.001 moles because that sodium hydroxide was the limiting reagent. Okay, so I've got, if you did your ice table, it would be this is the concentration 0.043 minus X and 0.028 plus X times X. And as before I said, you know, when you have your salt and your acid in solution together, you basically have a buffer, and so you can just use the Hausdorff equation, pH equals pKa times the log of the conjugate base, which would be this, divided by your acid. Plugging that in, you get 4.55. Now, the second problem on that PowerPoint, calculate the pH of 25 mils of 0.1 molar HAC, which is the acetic acid, titrated with 25 mils of 0.1 molar, and the Ka should be given. Okay, so now I've got 25 mils of 0.1, that's the acid, and I got 25 mils of 0.1 molar sodium hydroxide. And so you can really see if my concentrations and volumes are the same, you could calculate it, but you see you're at the equivalence point. There's nothing left. All the acid has been reacted with the base. And so now I have base, the conjugate acid, left in my solution. And so I've not conjugate base, I'm sorry, not conjugate acid. So my AC, the minus that was on the previous slide, can react with more water, which I don't show here, giving the protonated material, because now the acid is water, so the water gives up the hydrogen and puts it on the base, and the OH is left. So this was my concentration at the end of my titration. I had, as a product of this neutralization, my salt, and that's 50 mils of water, and I have 0 of this. Okay, so I'm dealing with the conjugate base, so now I have to find the Kb. The Ka was given, and Ka times Kw is a 10 to the minus 14, the ionization of water. So I divide that through, and I get Kb, and I can do my approximation again. And this number is so small here that most likely the approximation is going to be okay. So x squared divided by 0.05, which is my concentration here. I get x is my concentration of my hydroxide, equal to this. That's my x. The negative log of that is 5.27. And so 14 minus 5.27 is my pH at the equivalence point. And the last problem for 16.5 would be after the equivalence point. So your problem on your test is going to be either before, at, or after. And you have to decide where you are. Okay, so after the equivalence point, how do I know I'm after? Because I had the acid in there, 0.0025 moles, and now I've exceeded that amount. in moles. I've got 0.035 moles of base that has been added, so I have left over 0.0015 moles of base. No conjugate salt, no salt, and no weak acid. So NaOH is a strong base. There will be some of the acid, the base left, like in the previous problem, but it's going to be so small because this is a strong base that you don't need to actually calculate that. So I can take the negative log of my the base that's left over, and it had 0.01001 moles, and 35 plus 25 is 60 milliliters, or 0.06. So my POH is 1.78, and I want to calculate my pH. So it's 14 minus 1.78, and it will give me 12.2.